Ladies and gentlemen, imagine a machine that doesn't just compute faster but learns faster than anything ever built before. Imagine a system that can absorb the experience of millions of miles, billions of images, and countless real-world moments, and turn them into intelligence in days instead of years. What you're about to hear isn't a software update, and it's not a distant vision. It's a fundamental shift in how machines learn, how intelligence scales, and how the physical world is understood by AI. This is the story of a supercomputer built not to calculate numbers but to understand reality itself. And it's redefining what the future looks like starting right now. And the unveiling of the new DOJO Supercomputer represents a defining moment in the evolution of intelligent systems and large-scale computation. Built from the ground up to accelerate real-world AI, DOJO is not an upgrade to existing infrastructure. It is a rethinking of how machines learn from reality. At its core, DOJO exists to solve a single challenge: how to process vast amounts of visual data with extreme efficiency, speed, and precision, so that artificial intelligence can understand the world the way humans do, but at a scale no human system could ever achieve. And modern autonomy depends on data. Every second, millions of frames are captured from vehicles operating in diverse environments, weather conditions, and traffic scenarios. Transforming this raw visual information into actionable intelligence requires enormous computational power and a tightly integrated hardware-software stack. DOJO was engineered specifically for this task. Instead of relying on general-purpose processors, the system uses custom silicon design to handle neural network workloads with unmatched throughput and energy efficiency. This allows training cycles that once took weeks to be completed in days, and models that were previously impossible to scale now become practical. And the architecture behind DOJO reflects a philosophy of vertical integration. From the transistor level to the system software, every layer is optimized for AI training. Thousands of processing nodes are connected in a high-bandwidth, low-latency fabric, allowing data to move seamlessly across the system. This design minimizes bottlenecks and maximizes parallelism, enabling neural networks to learn from billions of data points simultaneously. The result is faster convergence, higher accuracy, and the ability to iterate at a pace that traditional supercomputing platforms cannot match. And energy efficiency plays a central role in the design. Training advanced AI models is traditionally energy-intensive, often requiring massive data centers with high operational costs. DOJO addresses this by delivering more compute per watt than conventional systems. By reducing energy waste and maximizing useful computation, the platform supports sustainable scaling as data volumes continue to grow. This efficiency is not just a technical achievement. It directly impacts the speed at which intelligent systems can be deployed in the real world. And one of the most powerful aspects of DOJO is how it enables end-to-end learning. Instead of relying heavily on hand-coded rules, the system allows AI to learn directly from raw sensory input. This approach mirrors how humans learn, through observation, pattern recognition, and experience. With DOJO, neural networks can be trained to understand complex scenarios such as unpredictable human behavior, rare edge cases, and dynamic environments. Over time, this leads to systems that are not only more capable, but also more adaptable and resilient. And the impact of DOJO extends beyond autonomy. Large-scale visual understanding, robotics, and real-time decision-making all benefit from a platform designed for rapid AI iteration. As models become more sophisticated, they require exponentially more data and compute to improve. DOJO provides the foundation for this growth, ensuring that innovation is not limited by infrastructure constraints. It allows engineers to experiment boldly, test new ideas quickly, and deploy improvements continuously. And equally important is how DOJO reshapes the development cycle. Faster training means faster feedback. Engineers can identify weaknesses in models, retrain with improved data, and validate performance in real-world conditions at unprecedented speed. This tight feedback loop accelerates progress and raises the overall quality of intelligent systems. Instead of incremental gains over long periods, breakthroughs can emerge in rapid succession. And the reveal of the new DOJO supercomputer signals a shift toward purpose-built AI infrastructure as the backbone of future technology. It demonstrates that the next leap forward in intelligence will not come from software alone, but from deeply integrated systems designed to learn from reality itself. By unifying custom hardware, advanced software, and massive real-world data, DOJO sets the stage for a new era of scalable, efficient, and continuously improving artificial intelligence. And this new era of computation unlocks possibilities that were previously constrained by cost, time, and scale. With DOJO, training no longer needs to be simplified to fit hardware limitations. Instead, models can grow in complexity to better reflect the real-world learning subtle patterns that emerge only when massive datasets are processed together. This shift allows artificial intelligence to move beyond narrow task optimization and toward a more generalized understanding of environments, interactions, and outcomes. And the system's modular design ensures that it can scale horizontally as demands increase. Additional compute tiles can be integrated seamlessly, expanding capacity without disrupting performance. This flexibility is critical in a future where data growth is not linear but exponential. As more vehicles, robots, and intelligent platforms contribute real-world information, DOJO evolves alongside them, absorbing new data streams and transforming them into improved models at an accelerating pace. And another defining aspect is reliability. Large-scale AI training requires systems that can operate continuously under extreme workloads. DOJO is engineered with redundancy and fault tolerance at every level, from hardware pathways to software orchestration. This ensures that training jobs remain stable, even when individual components encounter issues. By maintaining consistent performance under sustained load, the platform supports uninterrupted development cycles and predictable deployment timelines. And the tight integration between training and deployment further amplifies the impact. Models trained on DOJO are optimized for direct transfer into production systems, reducing the gap between research and real-world application. This alignment eliminates inefficiencies commonly found when models must be adapted to different hardware environments. The result is a faster path from data to decision-making, where improvements in training are reflected almost immediately in operational performance. And equally transformative is how DOJO enables learning from rare events. In complex environments, the most critical scenarios often occur infrequently, making them difficult to capture and model. By aggregating data at massive scale and retraining continuously, the system can identify and learn from these edge cases more effectively. Over time, this leads to intelligence that is not just optimized for common situations, but robust in the face of uncertainty and unexpected conditions. And the software layer orchestrating DOJO plays a crucial role in maximizing efficiency. Advanced scheduling algorithms distribute workloads dynamically, ensuring that every processing unit is utilized effectively. This intelligent resource management allows multiple training tasks to run concurrently without compromising performance. It also enables rapid experimentation, where new architectures and learning strategies can be tested in parallel, accelerating innovation across teams. And beyond technical performance, DOJO represents a shift in how AI development is approached culturally. Instead of treating infrastructure as a fixed constraint, it becomes an active enabler of ambition. Engineers are encouraged to think bigger, to design models that reflect the full complexity of the physical world, rather than simplified abstractions. This mindset change fuels faster progress and opens the door to capabilities that were once considered impractical. And the implications for autonomy are profound. As models trained on DOJO gain deeper situational awareness, decision-making becomes smoother, more human-like, and more reliable. Systems can anticipate actions, adapt to changing conditions, and respond with greater confidence. This continuous improvement loop, data collection, large-scale training, rapid deployment, creates a compounding effect where each iteration builds meaningfully on the last. And DOJO also lays the groundwork for future intelligent machines beyond vehicles. Robotics, manufacturing, automation, and large-scale perception systems all benefit from a platform capable of processing visual and sensory data at unprecedented scale. By unifying learning across different domains, the system supports the development of intelligence that can transfer knowledge from one context to another, reducing training time and increasing overall capability. And as computational demands continue to rise, purpose-built systems like DOJO redefine what is possible. They move AI development away from generic solutions and toward architectures designed with a clear mission. In doing so, they enable faster learning, greater efficiency, and a deeper connection between digital intelligence and the physical world, pushing intelligent systems closer to operating seamlessly within everyday reality. And this momentum carries forward into a future where intelligence is no longer constrained by narrow definitions or isolated datasets. With DOJO continuously ingesting real-world signals, learning becomes a living process rather than a periodic update. Models evolve alongside the environments they operate in, adapting as conditions, behaviors, and expectations change. This dynamic approach ensures that intelligence remains relevant, responsive, and aligned with reality at all times. And a key advantage lies in the way DOJO supports unified learning across perception, prediction, and planning. Instead of training separate systems in isolation, the platform enables end-to-end optimization where each component improves in concert with the others. Visual understanding informs motion forecasting, which in turn refines decision-making. This holistic training approach reduces inconsistencies and leads to smoother, more confident behavior in complex scenarios. And data labeling, often a bottleneck in AI development, is transformed at scale. Automated pipelines leverage existing models to pre-label vast datasets, while human feedback is focused where it adds the most value. DOJO accelerates this loop by retraining models rapidly as new labels are incorporated, allowing accuracy to improve continuously. Over time, the system becomes increasingly self-sufficient, requiring less manual intervention, while delivering higher quality results. And simulation plays a complementary role in this ecosystem. Synthetic environments can be generated to test rare or dangerous scenarios that are difficult to capture in the real world. DOJO enables these simulated experiences to be blended seamlessly with real data during training. This combination strengthens generalization, ensuring that models perform reliably not only in familiar situations, but also when faced with novel challenges. And the scale of computation also enables deeper networks with longer temporal awareness. Instead of reacting moment-to-moment, models can learn to reason over extended sequences, understanding how actions unfold over time. This temporal depth is critical for anticipating outcomes, coordinating complex maneuvers, and interacting smoothly with humans and other intelligent agents. DOJO provides the computational headroom required to train such models without compromise. And another important dimension is safety. Large-scale training allows for rigorous validation across an enormous variety of conditions. Edge cases that might go unnoticed in smaller datasets become visible and measurable. By identifying patterns that lead to risk and retraining against them, the system continuously reduces the likelihood of failure. Safety is not treated as an afterthought, but as an emergent property of comprehensive learning at scale. And the feedback loop between deployment and training becomes increasingly tight. Performance in the real world feeds directly back into the training process, highlighting areas for improvement. DOJO processes this feedback, rapidly turning observations into actionable updates. This cycle shortens the distance between discovery and improvement, enabling progress that compounds over time, rather than stagnating. And scalability also ensures longevity. As new sensors, higher resolution data, and additional modalities are introduced, the platform is ready to absorb them. The architecture is designed not just for current needs but for future expansion. This forward-looking approach prevents obsolescence and ensures that infrastructure investments continue to deliver value as technology evolves. And the influence of DOJO extends into organizational efficiency as well. Unified infrastructure simplifies development workflows, reducing fragmentation across teams. Shared tools, shared data, and shared objectives align efforts and accelerate collective progress. This cohesion allows breakthroughs in one area to propagate quickly across others, multiplying their impact. And ultimately, the system represents a commitment to building intelligence that improves through experience, scale, and integration. By anchoring learning in real-world data and supporting it with purpose-built computation, DOJO enables a trajectory of continuous advancement. Each iteration refines perception, sharpens judgment, and enhances adaptability, reinforcing a cycle where intelligence grows more capable with every mile, every frame, and every moment of learning. And this cycle of learning creates an intelligence stack that becomes stronger not through isolated breakthroughs, but through relentless accumulation of insight. Each interaction with the physical world contributes to a broader understanding of cause and effect, intent and motion, risk and opportunity. DOJO enables this accumulation to happen at a scale where patterns emerge naturally without forcing assumptions or shortcuts. The system does not simply react to data. It absorbs context, learns relationships, and refines behavior with every iteration. And as models mature, they begin to exhibit a deeper sense of spatial awareness. Objects are no longer perceived as static entities, but as participants in a continuously evolving environment. Motion, intent, and probability are inferred together, allowing predictions that feel intuitive rather than mechanical. This level of understanding requires enormous computational depth, and DOJO provides the capacity to train networks that can reason across space and time simultaneously. And the speed at which improvement occurs also reshapes expectations. Traditional development cycles often involve long delays between identifying a limitation and delivering a solution. With accelerated training and validation, those delays shrink dramatically. Engineers can push updates based on fresh data, test performance at scale, and redeploy with confidence. This rapid iteration encourages bold experimentation, knowing that ideas can be evaluated and refined quickly, rather than remaining theoretical. And another critical benefit lies in consistency. When intelligence is trained across massive, diverse datasets, it becomes less sensitive to regional differences, unusual conditions, or rare configurations. The system learns to generalize rather than memorize, recognizing underlying principles that apply broadly. DOJO's ability to process global data streams ensures that improvements are not localized but universally applicable. And the infrastructure also supports continuous architectural evolution. As new neural network designs emerge, they can be tested and scaled without rebuilding the underlying platform. DOJO's flexibility allows it to adapt to future advances in machine learning, ensuring that innovation is not locked into a single approach. This openness to evolution keeps the system aligned with the cutting edge of research, while remaining grounded in real-world application. And beyond perception and decision-making, learning at this scale influences efficiency and optimization. Subtle improvements in prediction accuracy can lead to smoother operation, reduced energy consumption, and more natural interactions. When intelligence understands the environment more precisely, it can act with less correction and fewer abrupt changes. These refinements compound over time, delivering benefits that are both measurable and experiential. And the role of data quality becomes increasingly important as scale grows. DOJO enables sophisticated filtering and weighting mechanisms that prioritize the most informative examples. Instead of treating all data equally, the system learns which scenarios drive the greatest improvement. This focus ensures that computational resources are used where they matter most, maximizing return on every training cycle. And collaboration between simulation and reality continues to deepen. Virtual environments can be adjusted rapidly to stress test assumptions, while real-world feedback validates outcomes. DOJO bridges these domains, allowing knowledge gained in one to enhance the other. This synergy accelerates learning while reducing risk, creating a balanced approach to development that is both ambitious and responsible. And as intelligence becomes more capable, the emphasis shifts from basic functionality to refinement. Subtle behaviors, timing, and interaction quality come into focus. These nuances are difficult to engineer manually, but emerge naturally through large-scale learning. DOJO provides the environment where such emergence is possible, giving models the space and data they need to evolve beyond rigid rule-based behavior. And the cumulative effect of these capabilities is a platform that does not plateau easily. Each improvement unlocks the potential for further gains, creating a self-reinforcing trajectory. More data leads to better models enable more confident deployment, and deployment generates richer data. DOJO sits at the center of this loop, transforming raw experience into structured intelligence at unprecedented speed. And this approach redefines what it means to build intelligent systems. Instead of static products, they become evolving entities that grow more capable over time. The infrastructure supporting them must therefore be equally dynamic, scalable, and resilient. By focusing on purpose-built computation, deep integration, and continuous learning, DOJO establishes a foundation where intelligence can expand naturally with experience, pushing the boundary of what machines can understand, predict, and accomplish in the real world.